Yes, sir, you are live now.
Hello. Hi guys, good evening. Is everyone able to hear me? Just checking those things first. You can reply in the chat. Is my voice is audible? Is everyone able to hear me? You can reply in the live chat. Hello.
Yes, sir. Yes, sir, you are audible, and we are good to go.
Okay, just hi guys. Good evening, everyone. I hope you all can able to hear me. Just you can comment in the live chat. Is my voice is audible? Maybe one or two comments. Okay. First of all, good evening, everyone, and special thanks to the ACM team for giving this opportunity to interact with everyone. So let's start the session. We'll be looking into the roadmap to AI, and at the end, we'll be looking the case study. So about me, I have a totally 10 years of experience in IT, and recently I just came out and working on my startup. I worked as an automation architect, and right now I'm a data science trainer. Parallelly, I am doing my master's in AI and also working on creating a complete data science course for free. That's working on that vision. Maybe this is a channel you can, if you want, you can visit this. Almost all the important topics I have already posted it here sequentially. So the agenda for today's session is we'll be looking into the overview of AI, machine learning, deep learning, data science, and big data. The reason behind this introduction is still people thinks AI, machine learning, deep learning are almost same, but that's not the real fact. We are having a big difference in each terminology and roadmap. Of course, that's the main objective of this session. Then when we talk about machine learning and deep learning algorithm, we will be comparing with the real-time application and some very important portals every data scientist or AI engineers must know. Those things will be shared. And if you want to start an AI project, how to start that. Then at the end, Microsoft Malware Detection using machine learning. So these are all the agenda for today's session. And regarding the expectations, there are three types of audience. Audience one, who are non-CS background, that is who doesn't know extreme programming, but have an interest on AI. For them, this session will be very useful. And second audience, it's like they are in IT or CS background, but still they know only theoretical stuff about the AI. For them also this is going to be a very useful session. And the third one is like who know well about AI, who are already a data scientist. For them, maybe the last topic, Microsoft Malware Detection, will be useful. So I'm just setting the expectation clearly. So before we start into the main core topic, first I have to give a hope to everyone, because still people thinks whether AI is really it came into the world, or we have any job opening like that. We have a lot of queries within us. And if you can see here the slide, in 2020 these are all the top 100 AI companies presently. uh, either company or a product which is available in the market around the globe, and you can see in every sector it has been implemented, starting from the healthcare, finance, mining, even food and agriculture, then education, manufacturing, anything. If you take construction, so whatever the field you consider, already AI came into the picture. In addition to that, cross industry technology like AI processor that is creating of the chips, then AI model development. For example, H2O is one of the trending product where AI is AI itself, and we can able to automate it from starting to end. Everything an automated process already came into the market. Then NLP, computer vision, that is a deep learning, using deep learning, creation of drones, identifying images, a lot of things already came into the picture, came into the market, and they are used. These are all some important companies presently competing in the market. So if you are going to prepare, definitely you have a very great scope. And one good thing about this is, for all the field, the prerequisite or the knowledge we are going to be the same. So you learn something, you know all the mathematics, you know programming language, you know algorithm. Then just by knowing some domain knowledge, you can implement your knowledge into that. For example, you know computer vision, you got some healthcare project that from an X-ray or from MRI scan, you want to detect some disease. That also can be done. Same thing, you get some images from a manufacturing thing. That also can be done. It's like a single knowledge we can able to surround over the field. So that's the biggest advantage of learning this technology. But only one drawback or pain point is it's a very long learning curve. Let me tell that how to prepare it in a very early way. So before that, first we will clearly understand about these terminologies. First thing, all these field, that is AI, ML, DL, everything falls under the computer science. So when you consider artificial intelligence, what literally an artificial intelligence? Right now everyone developing some machine learning algorithm or deep learning algorithm, finally they are creating some AI product, they are deploying their code in the web pages or something like that. But literally what is an AI, you must know it. And this is specifically for non-CS guys. So first we must know what is an intelligence. So intelligence means we are dividing into two types of intelligence. First one is natural intelligence. Nothing but if a task is done by us, it's called an intelligence. If we add our human intelligence to a machine, then that's called as artificial intelligence. So here we are going to learn how to add the intelligence to the machines. And he is a father of AI. So his name is John McCarthy. And for AI, there is no fixed definitions. So every company or a big shot persons or a scientist have their own definitions for AI. But most used definition is the science and engineering of making the intelligent machines. It is nothing but both the science and also engineering. We are clubbing it together in order to make the intelligent machines. So that's a simple definition. Now I'm going to explain very easy scenario, but we can correlate this to the real-time scenario. Maybe you can imagine this. So we have a small kid, 2 years or something like 3 years, and you kept a ball below a table. Now you are asking the kid, boy or a girl, it can be anything, you are asking him to go and take the ball. So first time when it goes from on his place to near the table, then it will go below the table. Once he take the ball, mostly he will try to stand. At the time what will happen, he may get hurt. So he understands something like below the table, if I take a ball I should not stand. Later he realized, so he came out the way he went. And second time, same scenario, what you're doing, you're just keeping a pillow in the way the kid goes. So some kids, what they will do, they will take a separate path. Some kids will jump on the pillow, some kid will play with the pillow and finally go to the ball and take it. So this is what happens. Just I'm making the same situation a little bit complicated. I'm keeping some rigid material like an iron ball. So what will happen? Of course, some intelligent kids will not touch this and will take a very good way without touching this. Some kid will try to hit this ball and understand that they can't move this ball again or they can't jump against this ball. So they will once again reach the destination. So now what we are doing, we are just keeping this kid in one room and the ball is in another room. So now once again we are asking him to go and take the ball, and he knows about this home and you'll definitely go and take the ball. So the simple scenario, I'm just making a little bit, I'm just adding few technical terminology. Source is nothing but he's starting, and destination is nothing but the ball he going to take. And the way he goes is nothing but search path. So these are all AI terminology. So he used the search path to reach the ball. If he does the first time, that's a normal way of finding. But if he use his past experience, that is called heuristic knowledge. That is based on the previous knowledge, he is able to take the ball. So source, destination, search path, heuristic, these are all the terminology we will be using in the upcoming slides. Now the kids played or the kid is trained inside the home. Now if you take this kid to a park and you put ball anywhere in the park, definitely the kid can able to take that ball. What how it happened is based on its previous knowledge, the kid got trained and the kid uses the heuristic knowledge and able to go and take the ball. This is called artificial intelligence. This is what we want to this is the thing we learned, and these things we want to implement to a mission. So training the mission, and the mission, the algorithm will able to predict the based on your previous experience. So that's in technical terminology. This kit example is a little bit easier example. You can correlate it very easily. Now the conclusion here is, when we talk about AI, it is a way of making a computer. It can be a computer, or it can be a computer controlled robot, drones, or any machines, or even a simple software which can able to think intelligently in the same manner how human thinks. So this is called as artificial intelligence. Hope you got a clear picture about the artificial intelligence. Then still people think like right now we are our aim is to come produce an AI application, but in 80s and 90s, what literally AI means, it's an expert system. Expert system means it's a piece of a software which uses the database of an expert knowledge to offer an advice or a make decision in such an area as medical diagnosis. That's a definition in layman terminology. For example, you are creating an expert system for medical diagnosis. For that, what you will do, you will go and talk to a consultant or a doctor who is very good in that field. Try to get all his knowledge and feed that to the knowledge base of that expert system, and you will write a logic. You can imagine like a flow chart. So a person is having a cough, a person is having a dry thing, something like that. It will try to validate every questions. Finally it will come up with a answer like, okay, this person having a headache. So this is called an expert system. So here, what literal thing has happened is everything was programmed. It means a static answer. So it works based on the pre-programmed in the rule engine. Based on that rule, whatever the question we ask, it will answer. This is the literally it was the one AI used in those days. Later, what happened? These things got machine learning, then deep learning. We will go into that. So, hope you understood what is an AI. In the AI, there is a subset called machine learning. So, when this machine learning became very famous is when you got so much of data. So with the data, with the previous you have a data, you're going to train the model with the data based on your previous experience or past experience. You're going to predict the future. Same like that kid example, he trained inside the home but still he can able to go and play in the park. Same thing. So here it's a little bit data knowledge here. So machine learning, which works based on self-learning algorithm using past experience or a data set without being explicitly programmed. That is very important. In the expert system, everything is explicitly programmed. So if you ask a question which is not in that, definitely it will not answer. So, but machine learning is something like it is like self-learning algorithm means an algorithm which can learn by itself and take own decision or prediction based on its previous thing. So that's what how can be done as implementation part. We will be seeing that, but it got trained with the data. So machine learning means first thing you should come to your mind is data. AI means expert system. Machine learning means with the data we are training the model and trying to predict the future. And inside the machine learning, there is a one more field got trended, that is called deep learning. So deep learning is nothing but we have the human brain, right? So the scientists want to replicate exactly how our brain works in a computer. So they are coming with a neural network. So this is a simple diagram. You can see like once again. So this is a one neutron, another neutron. So in our brain, we have for human brain almost 86 billion neurons are there. You can see almost 8,600 crores in Indian standards. So what exactly happens is when we see something, when we eat, so the information will be passed from one neuron to the another neuron, and this thickness layer will be there, and that when we do some task again and again and again, that layer will become very thick, and when we stop doing something, that will become thin, and one point of time it will get erased. I think as a child we will remember, we will start learning some 30 to 40, we will remember everything. After 60 you will start forgetting everything because we are not doing some those tasks again and again. So what happened is that layer between these neurons getting disappeared. So this is what happens in the real human brain. So scientists want to implement this in the mission. So what they are doing, this is a simple neural network. So for the previous diagram, that is between two neurons. Same thing here. The red color is an input layer, and we have so many hidden layers. Here, one hidden layer I have used, and the output layer is something. So it's like you're getting an input from your eyes, from your ears, saying that go and take that ball. So you got it pre-processed, and then output, your hand will go and take the ball. So this is how you can compare that with kid example. And the right side you can see this is in terms of mathematical network diagram. So inputs are nothing but like here eyes, every inputs, and weight is nothing but every input has its own weightage. We will see that technically in future. And finally you apply some logic whether I have to go and take the ball or not, that function. Then finally you will get the output, the child will go and take the ball. So this is what happens in our brain, and that's how mentioned it here like this. So now you have understood one thing, like what is artificial intelligence, what is machine learning. Inside the machine learning, we call deep learning nothing but exactly same like a human brain. So when these three fields are there, a new trending field came into the picture called data science. The reason because of big data. So here you must know the big data, then we will see what is a data science. So big data is nothing but data is divided into two types of data. One is structured data, another one is unstructured data. In 80s and 90s and all, you I think everyone at least know what is a database. In the database, we go and save some values, transaction details, names, employee details, and so on. So that will be in a well structured format. It's very easy. You can write a query and take it, and you can use it for your own modeling purpose. This unstructured data, when internet booming happened, we got so much of data from the internet, like images, audio, video, text. For example, if you want to sentimental analysis, means you can get tweets and understand something like that. From the Facebook you can take a lot of data. Like this, we have many datas which will be in a unstructured format. So the good or bad part is, right now, out of 100 percentage, 80 percentage of the data are unstructured. That's the first thing you must remember. Second thing, for almost from 1950 to 2000, the amount of data we generated, some x amount, means that data right now we are generating every day. It means you can understand how much data a company is having. That is a reason now the data science becoming very famous, because every model works based on the data. Now we must know how to handle this data or clean this data. And when you talk about unstructured data, we call this as a data lakes. We have a lot of data, and these can be structured or these can be cleaned using a few tools like Hadoop, Spark. We'll be seeing that. So that is a one thing you have to remember. So if it is a relational database, a simple model, you can go with MySQL tool. And if you have a data lakes, you must use Hadoop or a Spark. So if so, what happened is, when you consider deep learning, most data what we are getting is like an image and a voice, like that type of things, which can be done only or easily with more efficient with the help of deep learning. So when all these areas are trending, then a new field came that is called data science. Data science is nothing but, with the help of, it is a mixture of every department: DL, ML, AI, and big data. So so you understood now every terminology, but someone learn ML or DL or big data, but the final motive is we have to create an AI product. That's the one thing you have to remember. Now, initially I said AI product is an expert system. How about now? Now that has been what to say, upgraded. So initially, the questions we ask, it will have a predefined answer. Now you can remember chatbot. Initially, chatbot was developed with the help of machine learning. Now chatbot was they started using a deep learning for higher efficiency. I think recently Google was saying some voice automatically. It booked an appointment to a saloon. So those are all like an expert system. That is the latest trending AI product. So chatbot is one of a very important area in the AI product. Then any application which we are deploying it in the web server. And third product is, of course, like a mechanical product and other products like drones, self-driving car, autonomous vehicle, whatever it is. So all these falls under the third category. So based on your project, you have to sequence the learning things. That trick I will tell you shortly. So hope you all understood about these 5 terminology. I think I'm not getting any chat. Is everyone able to understood? Is everyone understood what these terminology in right now? You should not think anymore that machine learning, deep learning are same. It's like all of them are totally different with little bit with the examples which I taught you now. You have to remember those things. Okay, now we'll go into the roadmap to data scientist or AI engineer. So the what to say, the syllabus is common for any person who's in this AI field. So we have a lot of programming language like Python, Prolang, Java, but right now everyone started using Python at large scale because of multiple reason. I will tell that. So learning Python is very important. Now I will give a short overview, then we will pitch into each number in depth. So first you must learn the Python. When I say learn the Python, how depth means, basics Python is more than enough. That oops concept, object, classes, those advanced thing you can learn at the end are based on your project. If you're going to make a very big AI product with multiple folders, then you must go with the oops concept. Or in a single Jupyter notebook you're going to develop your product means basics Python is more than enough to start the ML and DL project. But once again the complexity of the project, but first you have to learn the basics things. Then knowing, as I already said, you understood the importance of a data. 80% unstructured data is available. It means if the small scale company, the startup companies may not have large data, so they will work with the MySQL. So minimum you must know how to work in MySQL. At least you should write a query and retrieve the data and pre-process it. That's a minimum thing you have to attain it. And if you're trying for a very big companies, they will be having a lot of data. So at that time you have to learn how to sort of tool. Then Python libraries we have, we like NumPy, Pandas, Matplotlib. We'll be seeing why we are learning those things. And readily available framework like TensorFlow, Keras, OpenCV. Like no need to create any framework. Already it was created after doing research for 10 to 15 years by big companies. We have a ready available framework. We can directly import and use it. And very important thing, our pain point for most of them is mathematics. uh, if it's a positive way, if you're really good in maths and if you're really in good in analytical thinking, especially in probability and statistic means, AI is the best area I can say, because almost everything whatever we want to implement, mathematics come into the picture. So what are all things to learn, we'll see it future slide. And based on the model, you already know by now what is machine learning and deep learning. So if it is a machine learning, we have so many algorithms, you have to choose one, you choose that. Or if it is a deep learning, we have only one algorithm, deep neural network. In that we have so many architectural way. We'll see that future slides. And finally, based on your project, you can choose the algorithm. How to choose, once again we will see that. So that's about an overview of the roadmap. Now we will see in depth about each point. When I said Python, why suddenly Python is so famous? Because it is literally easy to use, and even without knowing any programming language, or in, like, you can say this way, I can't waste my time on learning program, but I have a knowledge of mathematics, I have a knowledge of analytics. Can I able to code it means, definitely you can able to code it just by using Python language. So everything are predefined or well developed libraries available. You can call those commands and use it. And just to for motivation purpose, Python is used by almost all the big companies starting from NASA, Google, Facebook. These are all just few list used by big short companies. So Python is having a really very good scope. And how easy to learn Python, especially I'm from a mechanical department. Initially, before joining an IT, I thought, okay, how I am going to survive? Is programming is very tough or not? That type of thought process will be there for all non-technical or non-CS guys. For them, learning Python, just comparing with Python with C, Python with Java, you can understand the difference. Python is very easier. It's just like an English language. and no need of any programming background. Sometimes they will say, right, in order to know C++, you must know basics of C, something like that. In Python, no need of that one. And it is a very simplest programming language when compared to all other program. How? I will show you a very simple two programs to conclude that point. Just to print hello world, we have to write a lot of things in Java. You have to create the class package and create a main method, public static void main, then send the hello world. You can see it in the left side. But in Python, even without print, this will work. Just by mentioning this one line, hello world will print. Like this only, all the code will be done. You won't believe. So if you consider any AI application, mostly we can complete the coding in 50 lines of code also. I have seen some projects like that. So we will have a very single line which can do multitask work also. We'll be seeing that. And comparing C versus Python. So swap the numbers. Almost in the schools we will be doing it. We have to declare one. We have to take one temporary variable, then swap between these three variable. We have to do a lot of things for simple program. But just for Python, you're just declaring directly, even without a data type. Data type means you're sending a data. You have to tell in advance what type of a data. It's a number or a decimal point or it's a string. Like that, we will be doing it in C, in Java. But in Python, no need of that. It will automatically will take it. So you mention a comma b equals 6 comma 13 means a value is 6, b value is 13. And coding logic, directly a comma b equal to b comma a. You just swapping the number and printing the output. So this is how the Python programming language will be there. So literally it will be very easy to learn the Python basics. So first step is completed. Then Python library. So why we have to learn the Python libraries? Let's talk. We, as I said, we will have a lot of data. These data I have to go and save it in some place. So there comes numerical Python. A big data can be easily saved in a matrices form, that is row comma column way, and able to perform the operation very easily. Then I want to perform some operation into that in much better way. Then I have to learn pandas. And good part is pandas is developed above the NumPy. So if you learn Python, see, if you learn NumPy, then pandas is going to be very easy. Almost most of the methods will be repeating. Even without knowing NumPy also we can learn pandas, but I don't prefer that one. You guys first have to go with NumPy, then pandas, then matplotlib. Matplotlib means the one of the most important expectation of a data scientist is we will be interacting with the non-technical users or business persons. They doesn't know anything about code. Literally, that is a fact. It may be the client. They want the result, which we can convey that with the help of graphs. So you must have a very good depth knowledge about matplotlib. It is just drawing the graph that can also be done very easily. Then scientific calculation, if you are doing it, you can directly do that. And scikit-learn, machine learning algorithm, we can directly implement just one or two line that I can show at the end. So you no need to write a very big for logistic regression, linear regression. You no need to write any big code for that. Just call the logistic regression, pass the arguments, it will work. So these are all the main important Python libraries you have to learn, and based on your project you can add it. But prerequisite, NumPy, pandas, matplotlib, it is must learn thing. And whether you're working on deep learning means you have to learn something, machine learning means you have to go with the scikit-learn. So then comes the third important point. How much max should I know it? From here you can understand it's purely based on my research only. I'm just predicting this value. Almost 30 okay, 35, maybe the 35 and 30 got reduced because of the slides from the drive. From the cloud I'm sharing, that's why 35 and 30 got reduced. But probability statistics and matrix algebra itself will almost cover 65% of your whole part. So probability statistic used for so many purpose like data analysis and all, and matrix algebra, once again the matrices numpy come into the picture. And there are some mathematical logic, once again based on the project. Vector calculus, if you're working in a deep learning, at that time vector calculus will be, it's a very important one. Differentiations and all, it will come. Then other topics, once again it based on the project requirement. So minimum you must complete matrix algebra first priority, then probability statistics. So without knowing probability statistics, you can't touch any model. You may get codes from GitHub, you may train the model, but suddenly if I am giving a new scenario, because what we are learning and what we are working in a company will be totally different. So real time scenarios will be something like you won't get many materials from any of the resource. You have to put the knowledge what you have at that time. Probability statistics plays a very important role. So never skip the topic. Complete first priority matrix algebra, probability statistics, then move on to the next one. And vector calculus if you're working on deep learning. So when we talk about matrix algebra, these are all some important topics like transpose of a matrix, inverse of the matrix concept will be used for data encryption. Vectors, values will be mentioned as a single vector, row wise, column wise, everything will be done in the matrix algebra. And especially in terms of AI model, data pre-processing, data transformation, dimensionality reduction, model evaluation, all these things can be done only if you know a very good depth knowledge about these concepts. Actually some of them learned, maybe one favorite course is their very famous course. Almost everyone would have done machine learning without knowing the mathematics, but that is not the good approach. You must learn matrix algebra and probability statistics. And as I said, probability statistics totally play a very important role across the model from the starting stage till the ending stage. This will be coming with us, and especially while handling the data, mean, median, mode, standard deviation. I think we learned this in engineering. Those things, probability distribution, binomial, Poisson, normal. You must know which project needed binomial distribution. So it depends on a project. You have to apply the distribution. So if you know the distribution real usage only, then only you can choose a proper method. So these are all few things and used. You can see visualization, data pre-processing, all the things. Whatever we do it, definitely probability statistics will come. So that is the first two core point you have to learn in terms of max. Then database, as I already said, first complete learning the MySQL basics. Once you complete full syllabus, when you try for a bigger companies, definitely they will ask whether you know how to handle a big crunch of data. Even today case study, we are going to see a bigger data set of 200 GB data set. So that can be easily done with the help of Hadoop or Spark. Both of them are really a competitive product. You can learn anything after comparison. That's your wish, but prerequisite must you must know MySQL. So that's about the first 3 point: Python basics, then MySQL, then Python libraries, then mathematics, probability statistic, linear algebra. So we are not fully completing the syllabus. We are first completing the most important thing to start the machine learning or a deep learning. So we are just changing the sequence so that we can be able to create an AI product in a very short time. As a student, that is the best trick. When you try for a company, make sure the remaining topics are completed. So when I say about machine learning will be divided into three types. I think getting so supervised learning, unsupervised learning, reinforcement learning. We will see one by one shortly. If I say supervised learning, it means I got a data that is a labeled data. The data will tell, okay, this image is a dog, this image is a cat. So it's a labeled data. So whenever we handle with a labeled data, we categorize that to a supervised learning. So this is a simple diagram. When I say supervised, there is a one person called supervisor. He going to train us. Maybe as we parents trained us, so we are good. So they are our supervisor. Same thing for the machine learning, this algorithm, supervised learning, we will have a supervisor. And when we talk about the data set will be divided into two parts: training data set, testing data set. Once you complete the training, you will try to test your model with real data, whether you are whether the model is predicting properly or not. So that's what mentioned here. So with this data you will do the training and you will apply the machine learning algorithm, supervised learning algorithm. Next slides I will show you. Pre-process, then finally you create a model, and you can see this like in human. Actually this is a real time scenario. When you train it will be very easy, but in the real time, especially in the companies, we will come across images like this. So it's very tough to identify whether this is dog or this is a cat. So your test, your model should be able to identify it properly. So that's the thing. And finally it will say yes, it's a dog, not dog. And this is classified into two types. One is classification algorithm, another one is regression algorithm. Classification means like a boolean, true, not a boolean, binary, 0 or 1. So the left side you can see famous algorithm like logistic, navy, k-nearest, support. These are all very famous algorithm, falls under the classification algorithm. Example like we have an inbox which say whether the mail is spam or not spam. Then you do a transaction. What will happen? It will tell it's a valid transaction or invalid. For example, I'm in India. When I swipe, it will work. The second I travel abroad, or if you switch on your VPN and do a transaction, it will not work because the location changed automatically. The machine learning algorithm says that this is opened from a location which is not his previous location based on his previous data. So your transaction will decline. Then you have to call to customer care for activating the international transaction. That's a separate process. So everything works on your previous data. That falls under a classification algorithm. Then we talk about a regression means here it's going to be a real numbers in decimals. So left side like linear regression, stepwise regression, so many algorithms we have it. We have to learn these things. And for example, climate, you can't say it the single number. It will be keep on changing with little bit accuracy. And yeah, predicting the land price amount, real estate, it will be varying it based on so many factors. So these are all like regression algorithm. And second type, unsupervised learning algorithm. Here we talk about unlabeled data set. So there is no more trainer, there is no more supervisor. So you have a bunch of data, you're going to apply the algorithm to form the cluster. Cluster is a keyword you have to remember. When someone says about supervised learning, you have to remember supervisor, labeled data set, and a test and train data set. If it is an unsupervised learning, unlabeled data set, and then there is no training data set, it forms a clusters. So with this image, it will try to form this is a cat, this is a dog, this is elephant based on the program, some properties we define. For example, if you consider elephant based on if tusk, that is the teeth, you can say it mostly it will be an elephant. So it will our algorithm will apply on that image, and if this property match, put it in the class or put it into the dog cluster. Like that, clustering can be formed with the unsupervised learning. And some important k means, k medium, hierarchy, these are all some important thing. Then unsupervised learning can be divided into three types. Like in the starting we saw like no this one, classification and regression. Same way here, three types. First one is clustering. uh, uh, One real-time example is fake news detection. That is, it works on identifying the document analysis and understand whether this news is fake or not. That's a very, now it's a very interesting trending topic, clustering. Then association analysis, second category, that is market based analysis. A customer going into the shopping, they know if these guy buy these two product, definitely going to buy the state product. So those analysis we can able to predict based on his previous data set. So that falls associative association, having an association with another. If I buy a baby product, some eatables, diaper I will buy, milk I will buy, something, everything has some association, right? So those analysis can be easily done with these algorithm. And dimensionality reduction, when we work with the big projects, dimension becomes so many dimensions will come into the picture, features will come into the picture. How to reduce this? By using the PCA. Then extraction selections are there. Some real-time example is analysis of writing test or DNA microarray data. So some research area will fall under this category. Then reinforcement learning, third type of learning. Reinforcement means state and action. So you learn everything from the environment. Simple example, the robot is there, human is there. You're asking to play chess against a robot. What will happen? First game, robot will see what is the step they are doing it. First state, second state, third state. If I am cutting his coin, a robot coin means robot understood that if this step is done wrongly, he will take his piece. He will take the piece. So that will be considered as a penalty. For example, if robot dominates the human on a particular step, that will be saved as a reward, as a positive value, penalty as a negative value. Like this, it will be keep on adding the knowledge at one point of time. What exactly happens, it will try to win against the human. So that's how the best example is Tesla car that works with the reinforcement learning. Based on the environment, it will work. And we have a wide range of algorithm for reinforcement learning. If anyone having interest on doing research project, master's degree or something like that, a drones project, a mechanical project, everything falls under the reinforcement learning. Then application wise itself, we can divide into three category: optimization, control, monitor, maintain. These are all some real application. Some important robotics, autonomous vehicle falls under control. Then optimizing means you're trying to optimize the cost. Supply chain management is one of the trending area right now, it is going. Then fault detection. These things all falls under machine learning. Now next topic, deep learning. Why we have to go for a deep learning when we have a data in the machine learning? To be frank, whatever done by the machine learning can also, we can able to do the same project with the help of deep learning. Two reason, we have an enormous amount of data. You can see in the graph, this red color is nothing but a machine learning. When you train with a machine learning, what will happen? After one particular point, the efficiency will not increase. But when you use the neural network deep learning, what will happen? When you have a big cluster, a big amount of data, the efficiency will be keep on increasing. So if it's the same thing, the project, if you're done by machine learning, we can do that by deep learning, and it will improve your efficiency. And also machine learning can be done only if you have a data. But in the deep learning, even without a data, you can start the project, you can create your own data, you can generate your own data. So that's the two important reason why we are going for a machine learning, sorry, deep learning. And almost 27 architecture we have it. I'm not going into this. These are all the network diagram. So based on your project, you have to choose it. And these are all some 8 important things I want to discuss it. In an overview, I'm going to say what that network application important point which you must know it. So when first one, multi-layer perceptron neural network, it always flow input from forward direction only. You have 2 hidden layers mainly used for speech recognition, data classification, image verification, like that. And when this is used is to solve the complex problem involving several parameters. It means you have a data set. So this is the tips. You have a big data set which is having a lot of parameters. Parameters means input. That time the best part is go with the multi-layer perceptron neural network. And in that there is one more process called back propagation. If your project is having a lot of error prone project, then what they will do it, they randomly assign some weight to all neurons and they train it in the backward direction, and they find an exact weight for each neuron. So it's purely techie stuff. As of now, if you implement this thing, you can improve your efficiency or you can reduce your error. You can remember like that. And image recognition, speech, same thing. CNN, very important, convolutional neural network. When you're going to work with the computer vision, that is image, video, then you have to go with CNN, and it works well with the less parameters. And you can see video recognition, NLP, that's nothing but chatbots. Then pattern recognition, even recommendation engines also can be done easily with the CNN. Then recurrent neural network, this is also very important one. For example, this works based on the sequence prediction problem. Simple example, COVID. How they are predicting the COVID that October end will be the peak they will get it based on the daily data set. So they are sequentially seeing the data day by day, and based on that they are predicting. That falls under RNN. So whenever a data set, whenever a project you're working that falls under a sequence prediction, then go with RNN. Then LSTM, if your model is very large, you want to handle a very complex, then go with LSTM. So it's like a stock market prediction. You know very well that particular project, we can't stop that prediction, right? It should execute continuously. That's a very big problem, very big network complex sequence problem. There you can use LSTM. And can this is also very interesting one. You don't have a data, but you want to generate image from a given data set. High quality data set means even without a data, with the help of can, you can start it. Then comes the RBN. This is for it works for all the things like classification, regression, and generative model. And finally, DBN, especially for classifying high resolution satellite images. So when you want to improve, when you have a very good quality product, you can quality images, then you can go with the uh, DBN. So we now you may think we have these many architects, which one to learn. That once again I'll tell at the end how to choose the project. Then some important portal. If you decided to go in this area, that is AI or machine learning, first thing you must have a Kaggle account. In the Kaggle account only, they will be importing all the data, almost all the machine learning data set. You can find it here, and they will conduct some competition with a very high price amount. That's a thing you can learn under something called notebooks. If you search for notebooks, all the materials you can get it here. So you must have a Kaggle. And GitHub, where everyone import their project. A simple example, machine learning algorithm, I just selected it, searched it, and you can see almost 20,000 repository available, and you can filter based on the programming language from Matplot, Python, Jupyter Notebook, so everything. So all the data. So here two version is there. One is private, one is public. Private paid one companies will be using. Public is rest of them. So any data, any project, any research project, any AI project, first thing you can go and search code here. Even today's topic also you can get code here, and you can sort it with the best match timing. So Kaggle for data, GitHub for the code, and Google Colab. For example, you're working on a neural network, that is deep learning project. Everyone knows that when I want to work with deep learning, I have to buy a high configuration laptop like GPU. So of course financial problem will be there. At that time, we have an option called Google Colab. It's on cloud, Google product. Here you can train your model very easily. So you must have, if you are working on deep learning, use the Google Colab. In addition to these three, you must have a proper LinkedIn profile, because nowadays every HR is looking for good LinkedIn profile only. That becomes a very important ID for everyone, like FP. LinkedIn very important for professional purpose, and even in LinkedIn, everyone sharing their project, sharing their knowledge, sharing their every important content. Initially they won't do it, but last 2 to 3 years they started coming sharing their knowledge. So try to be a very active user in the LinkedIn to know the present trends. So these are all some important portals. Then comes the your how to quickly start the AI project. Mostly when I trained students, they will be doing some few mistakes when they start the project after theoretical part. uh, Half of them will sit or waste the time on data preparing. That is, they want to, as I said, no, your data decides the efficiency of your model. They spend a lot of time for a data. Of course, 70% we have to work on data, but initially don't waste time on the data. That's the first thing. And don't expect high efficiency in the starting itself. Two things you have to keep it in mind. So first, learn the Python basics, Python libraries, SQL, mathematics. Even sometimes SQL also needed if you have a good data set. Then how to learn this roadmap is, you have to choose your AI project if you're graduates, or a research project. Then search for that project in the Google literature review. Try to download all the PDF of that project. Computer vision, you're doing some drone project, download all the drone project PDF and learn everything. By end of learning everything, you will get so many keywords, what algorithm they used, what technology they used, what tools they used. Prepare that alone first. For example, you're working on, your project belongs to deep learning. To learn deep learning, no need of learning machine learning that much. Just learn linear regression, logistic regression. Just by learning these two topics, these two algorithm, you can directly start the deep learning. For example, you're working on a machine learning project. Then you have to learn all the machine learning algorithm which is related to your project. Then once you're done with this, you have a theoretical knowledge. Maybe you can Google the GitHub, get the code. First, build the prototype of that model. You don't waste time on doing analysis on your data. With the data what you have, maybe it is not a cleaned data, let it be. Just read, do a little bit of EDA, exploratory data analysis, and try to get the output. Because while what to say, while training the model, we will get a lot of errors, a lot of application or a software it will expect based on your project. First, those things needs to be cleared. So once you're done with this end-to-end product, this project execution, then what you can do is, okay, now you can go and clean the data set. You do the exploratory data analysis, feature engineering, visualization. We will be seeing all the three things. That 7, 8, 9 is the important topic in terms of interview. So you built a project, now you're going for an interview. They will ask all the questions from 7, 8, 9 only. So what is a project, how you did EDA, how you cleaned your data, how you handle the input parameter, how you visualize it. So all the basics what we have learned will be helpful for point 7. And 8 is nothing but fine tuning the model to increase the efficiency. Here this is linked to the algorithm. So you're doing little bit of modification to data or an algorithm to increase the efficiency. What are all the things you did in your project? They will ask like this. And finally, compare the model. So if you want to say your model is best, then you have to compare with other models. So if you want to compare with other model, you must know about that algorithm also. So 7, 8, 9 you have to consider as a high priority points. So learning wise basics, once you complete it, then sixth one is build a prototype model. Once you're done with it, 7, 8, 9, you just spend most of time into that and try to achieve an efficiency. When we talk about an efficiency, above 90 percentage is the minimum criteria. You have to get a good efficiency above that one. That's thing you have to keep it in mind. So this is how you have to start the AI project. Then for example, if you're from robotics, means it is having a different roadmap. You have to have a depth knowledge about that particular domain also, robots, sensors, how you're going to use the camera to get the image, process it, how this hand operation will happen. So these knowledge we can't get it here. You have to get it from the research papers that you can implement here. So that's how you have to do a very when you follow this roadmap, you can start the project just in few weeks once you're done with the prerequisite. Then next important thing, what is the salary of an AI engineer? This will not applicable for IIT graduates. For non-IITs, for freshers, I'm saying it will be between 10 lakhs to 20 lakhs rupees. I'm saying for Indians, INR. So very good pay scale. And one motivating thing is, for example, getting job after a fresher, after coming out of a college, is a very big problem. Even if you are a good developer in other field, a tester, whatever it is, mechanical engineer, civil engineer, but because of high demand in AI or machine learning or deep learning, if you can able to convince the interviewer, first what you have to do, you complete with your prerequisite, try to create the model, upload your code to GitHub, mention that GitHub link in the um, your resume. So what they will do, they will try to look into your GitHub. They will think, okay, you know something. Second thing, they want to confirm whether you did that thing or you just copied from someone else without doing anything. So you will come up for a telephonic interview. In the telephonic interview, if you properly explain your project, then only you will get the interview gateway. Then only you will be calling for the interview, and you have to go there. Then they will ask from the basics. Then as I said, that 7, 8, 9, from here only they can ask tough questions. If you really done a project properly, then you can able to answer 7, 8, 9 very easily. So as a fresher also you will get a job very easily. But if you are in the final year or third year, try for some intern. Even if you don't get a salary, also do some intern project. You will get a very exposure in the real time application. So that's about the roadmap to AI. So any doubt, you can ask me now. So the primary objective is completed. What you can do is you can post your queries in the chat. Then I can answer those things after session is over. Also, I can post my answer in the video comments. Like that we do it. Actually 1 hour is done. Now we will start with the Microsoft Malware Detection. I'll try to complete this as fast as possible. So Microsoft Malware Detection, when we talk about this, means very simple. What does a malware means? Any software which damages a software or a file which damage our computer or server or computer network. So these all falls under the malware side. And we have so many types of malware like virus, worms, trojanous, ransomware. Recently we got a ransom attack last year, and so many things we have it. So this is the simple definition of malware. And what is a project we are going to see is, we have a data set of around 200 GB data. It will be provided by the Microsoft. And they see here, almost when they started this competition in 2015, I think so, $16,000 was the prize amount. So this is a Kaggle. You will get so many competition, you can participate here. From here only you have to read the requirement. They will be clearly mentioned it, and the data set you have to download it. Here it's a compressed data set. 35.129. If you uncompress this, it will be 200 GB for sure. So if you want to work in this project means, definitely remember, you must have a good hard disk, you must have a good memory, then only you can work on this project. Code is available, so let me directly go into the expectation. Very simple. I'm giving a big data set. From that, what you have to do is, you have to identify the file is belongs to which class. There are 9 types of malware. uh, File, we have to detect file one is belongs to which type. Like that, you have to identify and do the classification. So it's a multi classification problem. So now, when you work on a real time project, first you have to define the business objective, what you're going to achieve it. So first thing I already said, 9 classes is there. You have to separate your file and keep it in one of the class. If that is a thing, first thing you have to estimate each probability properly. See, important of max started. So you have to clearly identify the probability of each class type, and minimize the uh, log loss. There is a one terminology you will get it. You have to minimize that, then only your efficiency will be high. In layman terminology, if probability increases, log loss decreases. It means for one probability, log loss is 0. If probability decreases, log loss increases. So our aim is to reduce the log loss. And third one, if you're doing these things, it should happen in a very quick manner, right? Like a quick scan. So you scan this. Microsoft will be scanning around how many computers? Around 160 million computers worldwide. It will be scanning Windows. So it should happen very fastly. These are all the objectives we have to keep it in mind. So first 3 scenario, the importance of probability. First scenario, you can see the file. You are giving an input file and it is saying the probability, it may be class 1 is 0.1, class 2.1, class 3.7, class 8.1. And you know very well, when you count, the final probability should be 1. So here we can come to a conclusion that file belongs to 0.7 probability. Simple. And second category, but see here, probability in the type 5 and type 7 file having a probability of 0.35 and 0.45, almost near to each other. In case if I am not using probability ideology or mathematics, what exactly happen here is, if I go with binary 0 and 1 means I may select type 7, which may not be true always. Sometimes this may be a wrong calculation. We may fall under type 5 also. So make sure we have to implement with the probability. When we go with the probability alone, we can achieve the high accuracy result. That's the thing you have to remember. Then data set, totally 20 GB. Here we have 2 type of files. One is ASM file, another one is byte files. So 50 GB will be of byte files and 150 GB of ASM files. I mentioned the link. You can read it in Wikipedia. So what we have to do is, in that, if we separate 10,000 plus files, falls under the byte files, and ASM files around 21,000. We have to read every file and just say which it belongs to which type. That's our requirement. If that is a thing, so this is how ASM file will look like. I will just, then byte file will look like. So this is like this is a token for every row, and this is the file, like here it's mentioned, it's an hexadecimal representation. So that's how the hexadecimal, that's how it will be represented in the byte file. Now we have to know what type of a problem it falls under. We have 9 classes, so it is a multi-class classification problem. That is the first thing we have to remember. Then when you will say your model is successful, based on two parameters. You can define any number of parameters, but for this case study, I'm taking two parameters. One is log loss, how much loss I'm going to reduce. Another one is confusion matrix, very important one. This problem, when they came up, they gave the evaluation factor as log loss. You have to implement this. So we'll see that. Okay, what I'm doing is, when we see the data set, we divided into two parts, that is test data, training data. Now we are dividing it into three parts. One is test data, another one is cross validation, another one is train data. So we will train with 64% of data. In that, we will do cross validation, whether that particular model is working properly or not. Then once we are done with this, then at the end, for the whole model, remaining 20% of data is considered as a test data. We will compare, or with this data, we will try to predict the model whether we are getting a proper efficiency or not. So that is the thing you have to remember now. Now, new terminology, cross validation. Just for validation, I'm using this. Then exploratory data analysis, you're just exploring the data step by step. So whatever I said, all the libraries imported here, and these are all the algorithm I'm going to implement. So directly you can import it. And initially we have a folder called we have a single folder. Inside that, ASM file, byte files are there. So a simple program will create two folder and divide these two files. Later what happening is, how our data looks like. So this will give an overview of our data. So because it's a labeled data, when I saw using the plot, I can understand that most of the files falls under 1, 2, 3 type. So this gives a very clear idea about our data. And class 5 is the one thing, 0.4% of files falls under class 5. So you will get, now you got a clear picture where we have to concentrate more, because 1, 2, 3 contains more data. Then feature extraction. What are all the parameters what are all the inputs we are going to pass into the machine learning to get the output? You may pass any number of features, but the final output is only one output, which cells that files belongs to which class. So first one is it will be in different size format. I am converting everything into a MB. So for code for that is this one, and this is the thing for that ID. The size is converted. Class 9. So head means top 5 data. It is displaying like this. I'm just doing a code walkthrough. I'll be sharing this document, then you can try it in your home. And finally, after doing this, I'm trying to do the box plot. This will give even a better idea about the data set. So what they are saying, for example, this is the size of a data between 0 and 2 MB. This many of data is there. For 2, it's like a very big thing is there, like an orange color. So that many number of files or size in that particular area, it will fall. Then 5 also, even though the data of 5 is very less files, but still it is bigger file. So there will be some intersection between data 2 and data 5. This is how some insight you will get it. This is like you will be used to it when you do the real project. Then second important feature, first feature is the size. Second feature is, this is the format of our input value. This is a token. I am removing it. And what I'm doing is, there is a concept called a bag of word concept. We use it in NLP. I am trying to convert this to a text file, and converting that to a what I'm saying is, we have a range of 0, 0 to FF. This is the range in which it will fall. If you count the combination, we will get around 257 or 256 combination we will get it. So what bag of concept will do, it will read each, this is 56, it will consider as a word, 8, 8D, 44, 24, like this. It will consider as a single word, and it will try to count how many times that particular word occurred. So finally what will happen is, it will do all the things, and this is how the result will look like. So 0 occurred 60 no 6 lakhs time, 1 occurred for 3905 times, like that. Every value occurred, how many number of times it will be displayed, and the combination is mentioned here: 1 2 3 4 9 0 A 0 B 0 C, like this. If you count, you will get 256. Yes, 256, one for size. And finally, okay, we are done with the main part. Now what we will do is, this is just to understand even multivariate analysis. Let me skip it. So by seeing this, you can understand how our data look like. So between 2 and 3 sizes, you have a big clusters, but 6 7 8 9 and all, like intersected. So data going to be somewhat issue, and we are trying with flexibility 30 and 50. I gave the definition for that. You can learn it here. So we'll go into the main part. So I'm splitting the data into training and testing data set, and now see the implementation. First, what I'm doing is, after splitting of the data, I'm trying to again seeing the distribution of our data. So it's like 27% of our data falls under class 3. So class 3 files, we have 1883 files in the particular data points per class. So like this, by seeing this image, you will get insight about the data set. Then what you will do is confusion matrix. This is a very important. So confusion matrix, if you want to understand by seeing this, is it's a very easy mimi. Actually what you're expecting and predicting value are same, means that's a true positive. You're saying to a woman that you are a pregnant, and the result also pregnant, it's a true positive, 1 1. And to a man, you're saying you can't be a pregnant, it's impossible, that's a true negative, it falls under 0 0. Now there is two more criteria. So 1 1 0 0, if it comes, there is a no issue. When it goes for a false positive, you're going and saying to a man you're a pregnant, actually it is impossible, so it's a false positive. And to a woman, actually she is a pregnant, but you're saying you're not a pregnant, so it's a false negative. So this is how we will try to put all our data into this 4 section, true positive or something like that, and we will see how many values falls under true positive and true negative, then come to a conclusion whether our model is good or bad. That we will see it right now. So first we are seeing the random model. Random model means you're giving a file that needs to be classified into any of 9 files, right? So now what I'm doing, I'm randomly generating the numbers in 9 areas, everything as a randomly, trying to find what is the worst way a model can work. Worst way in sense, if you give a random without following any proper process, the cross log loss for our test data will be 2.45, and it will wrongly classify 89%. This gives an idea what is the limit we have to achieve it. From 0 between 2.45, you have to bring your value, because this is the worst value. If you're getting a value above 4.45 as a log loss, means it means that model is totally waste. So what they are doing, this is just a confusion matrix. They will predict how many points, with actual one predicted one is 35 points, and everything in different scale. So they use the normalizing so that everything fall between 0 and 1. Now if you see 15%, 15.4% falls under type 1, both actual and expected. So our main aim is this diagonal should be 1. So if that is 1, then we are good to go. So like that, we have a k nearest neighbor classification. So applying the algorithm, as I said, it is just one line of code. neighbor classifier pass the respective input parameter. So you find it and you found k value equal to 3. So for this you must know those algorithms, so I'm not explaining those things, I'm just comparing the result and wind up. So what happened is for k and n we got output like this. This is a precision matrix, how precise our model works. So it identifies 73 percentage class 1 properly, 98.3 percentage class 2 properly, and class 5 if you see it, it means predicted class is 5 but its actual class is 8. That file should go to 8 but it came into the 5 cluster, something like that. So it means this thing is totally wrong. This 0.70 percentage, 0.761 also, it's not a good precision. So like this, then we are going with the logistic regression. Like this we will be applying all the type of models like logistic regression, then random forest classifier. These algorithms you have to learn it one by one. And if you consider random forest, see all the middle layer, this random forest is little bit or it's the best algorithm. If we apply, everything is almost near to 100 percentage, right? 96, 100, 100, 99 point. So it means this model is good. Then XBoost classification, one more algorithm you are applying. When you apply, the model behaves even better way. So this is how I said that last point, comparing the models. So you did same thing first for byte file, then for a .asm file for a. So before that we'll see the result. See for byte file, these are all the algorithms I applied. This is the log loss. What I said, we have to get a value between 0 and 2.45. When we apply k nearest, we got 0.48. Then logistic 0.52. But if you see here, this particular value random forest, it is 0.06. It means random forest is best for this model. Even XBoost classification works better than random forest. So it means these two algorithms we have to concentrate more. Then same thing, what you are doing is for .asm file. So here we are doing some research and choosing 52 parameters. And I forgot to tell, whatever I'm explaining, all the credit goes to Srikanth Verma. He is a faculty who taught these concepts. So when we talk about this data, this file will be contain 150 GB data. So if you're going to execute this particular model, it took 52 hours for me to complete in my GPU laptop. If you have a very less configuration and if you're working on this project, means definitely it will take a lot of time. So this particular line of code, this and this, will run for at least 2 to 3 days. You should not touch your laptop. And since it's a very big data set, 150 GB of data, what we are doing is we are implementing the very important concept called, here I have imported that particular library, multi-threading. I think CS guys know what is the use of multi-threading. Nothing but executing the data parallelly. So 150 data will be divided into 5 data set, 5 folder. In that 5 folder you will divide the 150 and keep it separately. Then with the help of multi-threading concept, you will execute it. That's what mentioned here. Folder 1, folder 2, folder 3, 5 folder, and final output will be in folder 6. So this will execute 2 to 3 days. Once you're done with this, that is what simply mentioned it here. And then what I'm doing is same thing, counting how many times that particular keyword is coming. So there are some keywords, like how initially we saw 256, same way this header how many times came, text how many times came, pop, like that. We are trying to find the count using bag of concept. Once again we are applying all the algorithms again, and finally we are coming up with some result. That is what here. So here, I don't know ISM out. So what exactly happened here is, so we are comparing this with the byte file. What we understood, the byte, that ASM file performs better than byte file. So misclassification in K-nearest is 12.97 percentage, but here it's just 4 percentage. When we talk about the log logs less means probability will be high. So it is 0.066 for random, it is 0.03. We reduced it. Then for exposed 0.504. So in this ASM data set, it performed even much better. And finally, we are clubbing the both data set and trying to execute for only these two algorithm, random forest and XBoost. So once again, same copy paste the code, and before that you have to club the data and execute it. I skipped that once again. So ASM, once ASM is completed, you're going to club both byte file and ASM file. So this is what that, clubbing both the files and executing the code. So what you're doing, you're displaying the byte file, your ASM file, then you're just merging it. So now 308 columns and removing unwanted columns just using the drop command. And same thing, uh, that is a multivariate analysis training. This data set divided into 80-20, applying the two algorithm. And finally, when we apply random forest, you got 0.04, and when you apply XBoost, you got 0.02 as the loss. It means even after clubbing, the percentage got reduced. And there are few more advanced concept you can implement that, and this is how the final result we have to showcase. Like what is an log loss we have achieved it. So when it's a byte file, the best thing we achieved is 0.07, 0.06 using these two algorithm. And when we talk about ASM file, 0.03, 0.04 using random forest exposed. So it means these two algorithms are best. When we clubbed it, we can able to achieve 0.02 by including some advanced feature. I didn't explain that. Even you can reduce 0.01. So this is how you have to conclude your model, saying that this is the best model, your efficiency is improved. So this is the main discussion area in the interview. How, what are all the models you have taken to the consideration, how you compared it, what things you have achieved, how you reduced or how you improved the efficiency and loss. Those things you have to answer it. So that's a short, it's a short, actually in order to explain this case study it will take at least 2 hours. I made it in 30 minutes. So that's about this case study. You can drop all your queries. I can answer you by saying that. If not, I will get the question from the admin and post the solution in the video comments. So actually I can post my LinkedIn into the video comment. You can directly contact to the LinkedIn. If you have any queries on your present existing project or future project, you can ask me. I can guide you on that. So that's from my end. Actually, sorry for taking 30 minutes extra. So we can wind up if we don't have any queries. Thank you, team. I'm not in the Telegram group. You can add it to me. I will add it. I will come into that and share all other details. Okay, guys. Thanks for joining today's meeting. You can ping me to my LinkedIn for other clarifications. I'm just ending the call. Thank you, guys. Thank you. Thank you so much.
Thank you, sir, for contributing.
Sure, sure.
Okay,
Thank you.
thank you.
Okay, okay. Thank you, guys. Bye.